Hi there, welcome back to the Cosmic Classroom. We'll now talk about star clusters and how is it that we can measure the ages of stars in clusters. Measuring ages is complicated and it can only be done in specific circumstances. Clusters are very useful to measuring ages because stars in clusters are all born at about the same time. So there are different kinds of clusters of stars. Some clusters are open clusters, like the Pleiades clusters that I'm showing you right here. So it's a cluster that's relatively young. You see a lot of gas still around the stars still forming. It's stars that have formed recently, actually. They are not still forming, but that have formed very recently. You still see the gas. So this is a pretty young cluster. And there are older clusters, like globular clusters that have millions of stars, and have redder, so the stars are redder. So just by looking at those two figures, we already have an idea that the Pleiades is younger because it's bluer, right? Than the globular cluster, which has redder stars. But how can we really put an age to those stars? Is what's the subject of this little video here. Now, you need to, in order to understand that, you need to go back and recall what an HR diagram is. So an HR diagram plots surface temperature and luminosity. So in the x-axis we have surface temperature, and hot is to the left, cold to the right. So those are hot stars, cold stars, and luminosity increases as you go up. So right here, there's the blue hot stars, and right here we have the red low luminosity stars. So if we look at the stars in the Pleiades, we can go to each star. You see a little triangle there? We can go to each star and measure its luminosity and measure its temperature. It's pretty handy to do that with clusters because we can measure the relative luminosity of stars. We don't need to know the absolute luminosity because they are all at the same distance from us. So all that really matters is whether this one is brighter or fainter than this one. It doesn't really matter, exactly how many joules are being emitted per second by this star or by that star, okay? So we can do that for different stars, and we can do that for all the stars that we see in the Pleiades, and we see stars all over here in the main sequence, but we don't see stars that are hotter than B stars. There is no star hotter than a B star. There are no star as hot as an O star. And in fact, the stars that are between, there's a late A star, early A stars right here, they are leaving the main sequence. So what this plot tells us is that all of the stars, O and B stars, they are not in the main sequence anymore. They have already died, okay? If they have already died, and we cannot find any stars with less than around 100 million years of life expectancy, we know that this cluster has to be more than 100 million years old. It has to have had time to form all the stars and to let them die, okay? As this cluster gets older and older, these stars are going to die, so they're going to move away from here. And then the colder stars are going to die and die and die. So the fact that we don't see bright O and B stars tells us that this cluster has had time for all the O and B stars that were formed to die. So the age of this cluster is around 100 million years. Right here at the other tip of the main sequence, there are stars that are still being formed. They are not quite in the main sequence yet. So all the stars are formed at around the same time from the same big cloud of gas, but you need to keep in mind that big massive stars do everything quickly. They form fast and they die fast. Okay, so in the Pleiades, for example, the low mass stars, the very low mass ones, you know, about 0.3 solar masses or so, they haven't finished forming yet. They are not completely born yet, but the O and B stars, the big massive ones, are already dead. Okay, so it's this studying in detail the stars that are already dead and the stars that have not even formed yet that tells us the age of the cluster. Okay, if this cluster was much older, you also wouldn't find any stars of type A, for example. They would also be dead. They would all be dead. So we call this the main sequence turnoff technique, and we can do that for many different clusters. So in here, in different colors, we have different clusters of stars. So for example, the light lavender here, Xi Persei, is very young, as you can see. 14 million years, it still has O and B stars, and just now those O and B stars are starting to die. The Pleiades cluster was here in green, and now the A stars are starting to die. Now the Hyades is another cluster, is shown in as this blue crosses here. You don't see any A stars anymore in the Hyades. So that tells us all the A stars have already left the main sequence. That tells us that the age of the Hyades is about 650 million years. If you look at the globular cluster, it's even more extreme. Look at the globular cluster. You don't have any stars to the left of here where I'm pointing with my mouth. There's nothing to the left. So all of those have died already. That tells us that that globular cluster is 7 billion years. If you wait another billion years, you won't find stars here either. So slowly the stars start dying from the left side of the diagram to the right side of the main sequence, and that gives us the age. Right? This is called the main sequence turnoff point. In here, I'm going to show you the detail of a globular cluster. Okay, so this is in the detail of a very old globular cluster. So what you see is that the stars like the sun, they are expected to live about 10 billion years. All right. So you see that in this globular cluster, stars like the sun are starting to leave already the main sequence. So they are dying. So this is a very old globular cluster. Okay, this is where they are leaving the main sequence and dying. You don't see anything more that's A, B, or even an F star. They are all dead already. Okay. Now you can only do that if you have many stars in a cluster to compare them. Right? Just by plotting one star here doesn't tell you anything. You need to look at the entire population in order to do that. And that's how we measure ages of star clusters. Okay? I hope it helped. I'll see you next time.